Efficient AI through mixer of experts. Agenda: Model architecture approaches, DeepSeek history, why DeepSeek matters, token routing lifecycle, getting started, basic workflow, MOE, and reasoning. Model architecture approaches. A language model's architecture decides how much of the model's total capacity gets used to process any single piece of input. If a model activates every single one of its parameters for every token, computational cost scales directly with the model's total size. Almost every large language model eventually has to decide between a simpler, fully active design and a more efficient, selective, active one. Any team training frontier scale models benefits from an architecture that grows total capacity without a matching growth in cost per token. Activating a model's entire massive parameter count for every single word doesn't scale cleanly as models keep getting bigger. Dense models and mixture of experts. A dense model activates all of its parameters for every single token it processes, regardless of what that token actually needs. DeepSeek instead uses a mixture of experts architecture, routing each token to only a small subset of specialized expert subnetworks. Dense, all parameters active, cost scales with size, simpler design, mixture of experts, DeepSeek version 3, 61, 67 1B total, 671 bytes total, roughly 37 bytes active. Only relevant experts run. Problems with dense-only architectures. Single point of cost. Every token pays the full computational price of what the model's entire parameter count. Right? Of that model's entire parameter count. Scaling a dense model's total capacity means scaling its per token compute cost by the same amount. Training and running very large dense models can require correspondingly enormous infrastructure and budgets. Specialized knowledge ends up spread across the same parameters used for every other kind of input. Growing model capacity for rare or specialized tasks still costs the same as growing it for common ones. Misses out on the efficiency of only paying for the specific capacity a given token actually needs. The DeepSeek system. Each token is routed by a learned gating mechanism to a small subset of specialized expert subnetworks within the model. Multi-head latent attention compresses the attention mechanism's memory footprint, further improving efficiency during inference. DeepSeek R1 builds on this same efficient architecture, adding reinforcement learning specifically focused on reasoning tasks. Other well-known large language model families: OpenAI's GPT series, Meta's Llama, Alibaba's Qwen. DeepSeek advantages: mixture of experts lets total model capacity scale without a matching increase in per token compute cost. Reported training costs dramatically lower than comparably capable dense models. Open weights released under the MIT license let anyone download, run, and modify the models. DeepSeek R1 matches strong reasoning performance while remaining openly available. Efficient architecture choices like multi-head latent attention, reduce memory, rapid adoption demonstrated real-world demand for openly available, efficient frontier-class models. Everything is routed to a few experts, almost. One huge benefit of this design is that in DeepSeek's models, almost every token is handled by only a small fraction of the model's total experts. A learned routing mechanism decides per token which handful of specialized experts should process it. This means the model's total parameter count can grow enormously while the compute cost per token stays comparatively modest. Because different experts can specialize in different kinds of patterns, the model can develop focused capability without every parameter needing to handle everything. This expert routing architecture is the technical foundation behind DeepSeek's combination of scale and efficiency. Experts and routing expert, a specialized subnetwork within the larger model. Routing, deciding which experts handle a given token. A simplified MOE routing step. Each token is routed to a small subset of experts rather than the entire model. A simplified GRPO-style reward step. R1's reasoning training uses rule-based rewards for objectively checkable tasks. History: DeepSeek was founded in May 2023 by Lang Wenfeng, who also co-founded the Chinese quantitative hedge fund Highflyer. The company grew out of Highflyer's AI research unit based in Hangzhou, China, aiming toward general-purpose AI capability. DeepSeek v3 was released in December 2024, trained for a reported cost of around $5.6 million, far below comparable dense models. DeepSeek R1 followed in January 2025, adding reasoning-focused training and quickly becoming one of the most widely used AI apps. Its rapid adoption in late January 2025 coincided with a significant stock market reaction as investors reassessed assumptions about AI infrastructure spending. Why DeepSeek matters? Efficient mixture of experts lets massive total capacity scale without matching per token cost. Open model weights are released under the MIT license for anyone to use and modify. Cost effective reported training costs well below many comparable frontier models. Capable DeepSeek R1 delivers strong reasoning performance in an openly available model. Influential its release reshaped the conversations about AI infrastructure costs industry-wide. Actively developed, successive releases have continued refining efficiency and capability. GRPO reasoning training. Group relative policy optimization trains reasoning by comparing groups of sampled responses against each other. Rather than requiring a separate critic model, GRPO scores multiple sample responses and reinforces the relatively better ones. Rule-based rewards, like a correct math answer or passing code tests, provide an objective training signal. Never assume DeepSeek's reasoning training was purely automated. Supervised fine-tuning and human-verified data played a role alongside reinforcement learning. DeepSeek token routing lifecycle. Input representation token. Select top experts route. Run selected experts process. Merge weighted outputs. Combine. A token is represented or routed to a handful of relevant experts, processed by only those experts and combined into one weighted output. Getting started with DeepSeek. This leads us to the three steps that get your first conversation going. Choose an access point. Use the chat app, API, or self-hosted open weights. Pick a model. Select V3 for general tasks or R1 for reasoning heavy ones. Submit a prompt. Type a question or task in natural language. Basic workflow, routing, reasoning, and responding. Some call route, reason, and respond. DeepSeek's everyday loop. Each token is routed to a small set of relevant experts as part of ordinary processing. Reasoning tasks benefit from R1's reinforcement learning trained step-by-step approach. Open weights mean the same model can run through a hosted API or entirely on your own hardware. Rule-based rewards during training ground reasoning ability in objectively checkable problems. Supports many workflows: coding, math, research, and general-purpose conversation. Works the same whether accessed through DeepSeek's own app or a self-hosted deployment. Any questions? Thank you.